Hello all. Today we will discuss the topic performance characteristics of measuring devices and types of errors in module 5. We need to know the performance characteristics of instruments for selecting the most suitable instrument for measurement. There are two types of performance characteristics. One is static characteristics and second one is dynamic characteristics. The criteria defined for the instrument which are used to measure quantities that are varying very slowly or that are almost constant with respect to time is called static characteristic. All the static performance characteristics are obtained by a process known as calibration. You already have studied what is calibration. Calibration is a process by which you compare the instrument with a standard. The main static characteristics of a measuring instrument are accuracy and precision, sensitivity, linearity and hysteresis, repeatability and reproducibility, resolution, drift, span, threshold, etc. We'll see one by one. First static characteristic is accuracy and precision. Accuracy is the degree of closeness of the measured value to the true value, and it is expressed in terms of static error, which is equal to measured value minus true value, whereas precision is the measure of reproducibility of an instrument, or how the successive readings comes close together. Accuracy can be improved by calibration, but precision cannot be improved by calibration. Next is repeatability. It is the ability of an instrument to reproduce a certain set of reading with a given accuracy when same precise input is applied several times. Next is linearity. Linearity means how well the input-output relationship of an instrument follows a straight line. That is, if you plot a input versus output graph, if the instrument is linear, it will follow a straight line. Usually we prefer a linear instrument, but in practical systems it will show some deviations as you see in the graph. Next characteristic is hysteresis. You can see here when you increase the input like this, the output also start increasing, but when you start decreasing the input, the output decreases through another graph or another curve. So the difference between the two curves, the input curve, the difference between the two curves, that is, one curve is this, that is when input is increased, and the second curve is this, that is when the input is decreased. So the difference between these two curves is called as hysteresis. Next is dynamic characteristics. They are responses of an instruments or system to inputs which vary with respect to time. Till now the input when we were discussing about static characteristics, the inputs were constant with respect to time, but when the input vary with respect to time, the instrument may not respond instantaneously with respect to that change in input. The instrument may exhibit slowness or slackness due to things such as mass, thermal capacitance, fluid capacitance, or electric capacitance. Various dynamic characteristics of an instrument are speed of response, fidelity, time delay or lag, and dynamic error. Let's see one by one. First one is speed of response. It is the ability of the system to respond to sudden change in input signal. Next is fidelity. It is the accuracy by which the instrument indicates the change in measured variable without dynamic error. Next is lag. It is the delay in response of an instrument to the change in measured variable. There are two types of lag. process lag, and control lag. Dynamic error, we can say that it is the difference between the true value and the actual value when the parameters are changing with respect to time, and when we are assuming that there is no static error. Now let us discuss the types of errors in measurement. As you know, the error is the difference between the true value and the measured value. And the errors in the measuring systems can be classified into: first one, gross error or human error; second one is random errors; and third one is systematic errors. We'll see one by one. First one is gross error. It is also known as human error because it is mainly occurring because of the instrumentation misuse and calculation error and other human mistakes like mistake in reading and recording, etc. It usually occurs because of the carelessness or lack of experience of the human being conducting the measurement, or due to incorrect adjustment of the instrument. So we have to avoid this error. This error can be avoided or minimized by taking good care while taking the reading and recording and calculating the results. And also another method is by um, taking the multiple readings, preferably by different persons. Random errors in an instrument is associated to random causes like electronic noises, interferences, etc. All random sources are independent. Next type of error is systematic error. It is a constant uniform deviation of the readings from the true value. There are three types of systematic errors. One is instrumental error, second is environmental error, third one is observational errors. We'll see one by one. The first systematic error is instrumental error. It is mainly due to the problems of the instrument. The instrumental errors are mainly due to three reasons. First one is shortcomings of the instrument. These are because of the mechanical structure of the instruments. Example, friction in the bearing. Another one is irregular spring tension, hysteresis, gear backlash, etc. They can be eliminated by selecting proper instrument and transducer for the instrument, and also to recognize the effect of such errors and apply proper correction factors. We can eliminate or control it by calibrating the instrument carefully against a standard. The second reason of instrumental error is misuse of instruments. A good instrument, if used in an abnormal way, will give you misleading results. So it can be eliminated by intelligently and correctly using the instrument. Another reason of instrumental error is loading effect. The loading effect will come due to improper way of using the instrument. So we can avoid the loading effect by using the instrument in a correct way, and also we can apply loading factors in order to overcome the instrumental error due to loading effects. The next category of systematic error is due to environmental errors. That means errors due to external conditions. The various external factors are temperature changes, pressure, vibration, thermal EMF, stray capacitance, cross capacitance, etc. So this can be eliminated by different ways, like using proper correction factors and using the instrument catalog, and also we can control by using temperature and pressure controlling methods, and also by reducing the effect of dust, humidity, etc. and also by reducing the effect of external magnetic field and electrostatic fields, we can reduce the effect of environmental or other external parameter influences. Next category of systematic error is observational error. These errors are introduced by the observer while observing the reading or while taking the reading. Few sources are like parallax error while reading the meter, wrong scale selection, habits of individual users, etc. They can be eliminated by the use of instruments with mirrors, instrument with knife edge pointers, instrument having digital display, etc. Other than the three categories, errors can occur due to other factors also, like the effect of time on the instrument. That can be also called as aging of the instrument. So as time goes on, there is a possibility of change in the calibration error of the instrument with respect to time. That can be avoided by periodic calibration. Another such error is mechanical error. That will occur due to increase in friction between stationary and rotating parts and residual torsion in suspension wire of the instrument. So regular maintenance and checking, by that we can reduce such errors. Types of errors and characteristics of measuring instruments. So that's all from in this class. We'll continue the class in the next video on the topic transducers. So thank you for watching.